Right, so when we are presented with a partial fraction question, the first thing that we need to do is to establish what the starting point is with our constants. So we look at the denominators, and what we see here is that we have a pair of linear factors. Both of those have no quadratic factors, and they have no repeated quadratic factors with power. So that is a straightforward equivalence where we have that being equivalent to a linear constant over y minus 2 plus another constant over y plus 1. We then combine, so our equivalence, we want it all over the same common denominator. So when we divide y minus 2 into that, it leaves us with y plus 1. So we multiply the a constant by y plus 1. Then when we divide the y plus 1 into it, we're left with the y minus 2. So that's what we multiply that by. So the equivalence here, we have equivalent denominators, which means that the numerators must be equivalent to. So 3 must be equivalent to a y plus 1 plus b y minus 2. It's down to you then how you choose to solve it from there. So the first method you could do is to choose a value of y which would eliminate one of the constants. So if we let y be -1, you'd have 3 on the left hand side. That would become 0, and that would become so 0 a plus b minus 1 minus 2. So 3 is minus 3b, so b is 3 over that minus 1. I've put in every step there. You can take whatever shortcuts you want. Then to work out the other constant, choose a different value for y. This time we'll leave y equal 2. That will send this to become 2 plus 1 is 3a, and the b constant to be 0. So a is 1. So therefore our equivalence of that is going to be a 1 over y minus 2 plus b, which is -1, which will make that minus 1 over y plus 1. The mark scheme for that is, there's only 3 marks for it. It's a very, very straightforward piece of maths for a C4. You get 1 mark for the method of getting down to your equivalent numerators, and then you get an answer mark for the correct value of b and an answer mark for the correct value of a. If you had decided you would rather the alternative method for this, which is setting up simultaneous equations, I'll just set those up for you. So there are no squares, so there'll be a y to the power of 1 coefficient. 0 on this side, there's no y component on that side, and we'd have an a plus b ay plus by on the right hand side, and then the number only, so y to the power of 0 would be 3 on the left hand side, and a minus 2b on the right hand side. So to eliminate with that, if we did 1 take away 2, we'd have 0 take away 3 equals a take away a gone, b take away negative 2 makes that 3b, so b is minus 1, and then you'd substitute that into the other one to solve that. So whichever method you choose, doesn't matter, the method mark is for the line above and the 2 answer marks are for the final values. So that's out of 3. The second question was a binomial expansion. I put up there the extract from the formula book just to remind you of what you'd be aiming to use. Find the first 4 terms of the binomial expansion of the cubed root of 1 minus 2x. State the set of values for which the expansion is valid. So we need it in the form 1 plus something to a power. So the first thing we need to do is to write that in index form. And again, we're talking about A2 year 13 A-level maths here, so I would imagine you're comfortable recognizing that you would write a cube root as to the power of a third. In this question we've already got the 1, so we don't have to worry about taking any common factors out, but we do need to be mindful that when we substitute x into our expansion, it's this whole minus 2x that goes in. So for us, we start with 1, then n is a third, and x is minus 2x. And this question wants us to find the first 4 terms. Well, that's the first term, that's the second term. So the next term now is going to be a third times a third take away 1, which will be minus 2 thirds, minus 2x squared, all over 2 factorial. And then the final term, first, second, third, fourth term, will be a third minus 2 thirds. Take another 1 off, and we get minus 1 and 2 thirds, which is minus 5 thirds, minus 2x all cubed over 3 factorial, and so on. Now let's start tidying things up. We get 1 minus 2 thirds x. Now here I've got a negative, that's going to become positive when it's squared out, so we're going to have a positive times a negative, means overall it will remain negative. Then we have 4, 8 on top, and on the bottom we have 2 times 9, which is 18, and x squared. And then on the fourth term, that will become positive, but that will become negative because we're cubing it, so we'll remain with a negative term. The top of this, we're going to have 8 times 10 is 80, and on the bottom we're going to have 6 times 27 x cubed plus dot 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 dot. So finally then, to tidy that up, minus 8 over 18 becomes 4/9, and this becomes 40 over 81. So there's our expansion, and then with questions like this, the final thing we need to do is look at what it's valid for. In general, the expansion is valid for the modulus of x is less than 1. So for us, we haven't got x, we've got minus 2x must be less than 1. So if you don't like working with modulus, that means the same thing as that minus the value of minus 2x must resolve to be, or evaluate to be, between -1 and 1. So to get the x on its own, if I divide throughout by -2, what you have to remember with inequalities is whenever you multiply or divide by a negative number, the inequalities reverse. So that becomes a half is greater than x is greater than minus a half, which means that the modulus of x is less than a half. So you can either leave it like that, or you can reverse those now, and basically that's saying x is any value greater than minus a half and less than a half. So whichever way you wish to write it, it doesn't matter. As far as the marks for that are concerned, just realised I've used my red pen. The marks awarded for that, there's 1 mark, standalone B mark, for writing that correctly in index form. Then there's a method mark for each expansion written out there. You don't have to evaluate it, but you have to make sure that these coefficient parts are correct. And then there's 1 mark for this part, so that's 1 mark. And then there's 1 mark for that final answer and 1 mark for that final answer. And then there's 1 mark for your correct validity in whatever way that you've decided to write it. So that should be 6 marks. 1, 2, 3, 4, 5, 6. Yeah. So there we have it.